Fernando has a question that he would like to ask. I don't know if he asked it in the chat. If you're in the backstage, Fernando, feel feel free to go ahead and ask.
Okay, I guess I can use my power, right? That's to make the question like this. Okay, no, that's good. Thank you. Thank you very much.
By the way, if anyone else has questions, I can. I think I can, if you raise your hand, I can bring you to the stage and you can ask it live on air. So, yeah, over to you, Fernando.
Sure. So I had a question to Radostin. What's the difference in the value of having the P4Pi running in a Raspberry Pi versus having this running on a student laptop? I'm just wondering because I'm planning to use this in my in my courses, but the fact is that here in my students here in Lisbon, they do have laptops, so I'm wondering if there's any value to switch to Raspberry Pi in that case.
Student engagement. So by having a Raspberry Pi, each student has their own device and they can program their own, well, they can implement their own solution of a P4 program, for example, data plan, etc. But it also allows them to interact with other students. You can imagine a class full of, for example, a class of 10 students. Each student has their own Raspberry Pi, and then they can connect the Raspberry Pis to create a network, and then they can run tests. In this case, we demonstrate building an internet router, and then you can basically test the interoperability between different designs of the network. So this is the main value is the hands-on experience with using real hardware rather than a virtual environment with Mininet. But of course, developing the code in a virtual environment is easier than if you isolate in the Raspberry Pi and so this is the main reason why basically the compatibility between running tutorials, for example, in a virtual machine, and then running the same tutorials on the Raspberry Pi is simple and easy. Does this answer your question?
Sorry, I was muted. Yes, thank you.
So, okay, you said another advantage of using a copy is that you can. It's small and low power, so you can put it on a drone. And I'm not sure if Andy's serious or joking with that, but that's a good point. You can put it in different environments because if it's a large switch or to an FPGA. And also to follow up on what on Radustein's response about having real hardware, this this year I had experience the build your own internet router course, and we did it all in BMB2. And in previous editions, the course at Stanford was taught on using FPGAs, and with this new edition, all BMB2 based, the feedback we got from the students is that they missed the physicality. They missed to touch the hardware and deploy their switch implementation onto a real device. So in the past, in this course, there'd be an interoperability experiment where each group would connect their the FPGAs together, and when a packet goes through, just the excitement they got from that, from knowing that they programmed the switch and it works. And that's on hardware, and I think that's different than having that running entirely in software. So, one question I had for all the presenters is it's about the challenges they had, which I've already asked a few for their implementation. but also more broadly, P4 ecosystem. We talk a lot about programming these devices with P4. What else? Maybe not the language itself, P4. What else do you wish were part of the ecosystem? For example, the controller. Radosin said that P4 runtime is partially supported in Poppy, and this is I think something my experience about. I can write a P4 program and deploy it. But there's getting it to integrate with the controller is not so straightforward. What are your feelings on that? Guillaume, do you have a?
Yes. So in a more like kind of production towards gearing towards production at the end of the day, we're facing like a problem at the moment, which is quite interesting. Is how do we integrate with CI/CD when we get all this new code and control code that is supposed to control the switch or anything? How do we trigger CI/CD pipeline to check that everything that we pushed in the repository is still working and it's doing some unit testing? So that's something that a lot of people in the FPGA community are starting to realize as well. So it's still a very open problem for the FPGA, and I think it's the same with the P4 community and the networking community at the end of the day. Because now the P4 switch is not a switch anymore. In our case, it's just part of an instrument. So it's just need to validate that it's doing what it's supposed to do using CI, and that's what CI/CD is supposed to do for you. You push something and it tells you like, oh, you failed. Go fix your bug. And I haven't seen anything yet there. So if anybody's got something there, please send me a message. I'll be more than happy to have that.
If anyone, has any suggestions for Guillaume, that would be great. So going in what Moritz presented for the IPv6 or array guard, there's some interaction between the control plane and the data plane, and then his implementation that there is looks like he thought in the interface between the control plane and also how you came up with tools to configure it. Moritz, what do you think was would you have liked to have had? What would have made the process simpler?
I don't completely understand the question. Need for the interface?
Yeah, push, but the controller you used, and did you use P4 runtime? What, let's say, what did you have to implement that wasn't already there, that wasn't included in the book?
Controller, I implemented the whole learning process, so the extracting of the relevant information and setting up the forwarding and the filtering tables. But yeah, it was quite a straightforward process. So you're asking what I've implemented. I'm not completely sure if I got the question.
Okay, I think you answered that. I was just curious about what controller you were using.